So, talking about mass and weight. When we're talking about mass, right, mass is the amount of substance within a given object, right?
Yes.
And it's measured in kilograms. Weight is the force of gravity on that substance, right? So, weight is a force and mass is a scalar quantity, right? Remember what scalars and vectors are?
Yes. Sorry, there's a delay in my audio though.
It's fine. So, what is a scalar quantity? What is a vector quantity?
Scalar has like size but no direction. For example, mass, temperature, and time, speed. But a vector has that and a direction. For example, displacement, velocity, force.
So, weight is a force, hence
Scalar?
it's a vector because forces
Oh,
are vectors. Okay. The standard unit of mass is kilogram, with the gram being one thousandth of a kilogram. So mass is different from weight, whereby gravitational force on an object with mass is weight. So weight is the force of gravity on an object with a mass. Yes?
yes.
Okay. So different places will have different gravitational field strength. Yeah.
Yes.
We're talking about the Earth, it has a different gravitational field. If we're talking on the moon, it has a different gravitational field, right?
Yes.
So what happens is the force of gravity is different on different astral planes, right? Different planets, different, you know, um, they're called heavenly bodies in a sense. When we talk about moons, when we talk about planets, right? So they're called heavenly bodies as well. So they all have different gravitational field strengths. Therefore, there is a different force acting on the mass, whether it's the same on Earth or the same on the moon. The mass would remain the same. However, the gravity would change, hence the weight would change.
Yes.
Okay.
Yes.
So the unit of force is Newton. Hence, the weight is measured in newtons because weight is also a force. So kilograms, newtons, measured using a balance, using a spring balance, right? Mass is not dependent on gravitational field, right? But gravitational field is dependent, or weight is dependent on the gravitational field. Hence, it has, it is dependent on the gravitational field. So gravity acts through space, causing objects not in contact. So it's an attractive force which does not require both forces or both objects to be in contact. Right? They just have to be in proximity. Right? For example, when an object is suspended on the earth and it's let go, it comes towards the earth. Right? So due to gravity. Gravitational field strength G is the force per unit mass and its vector quantity with magnitude, and it is a vector quantity with a magnitude and direction, right? On Earth's surface, gravitational field strength is 9.8 newtons per kilogram or 9.8 meters per second square. It can also be defined as an acceleration due to gravity, right? So 9.8 meters per second is the acceleration due to gravity. How can I say that? Do you remember what is the unit for acceleration?
No.
It was speed over time, right? So meters per second. So minus minus becomes minus 2. So ms minus 2. Yeah. Okay.
Yes.
Or meters per second square is the same here, right?
Yes.
So we can call this acceleration due to gravity. Representing both acceleration due to gravity and gravitational field strength. Now we're talking about density right after this. Density, yeah, density. We're talking. Okay, so this is the balance or the what is it called? It's called a spring balance, right? So the force on this can be read in newtons on the scale, right? Make sense?
Yes.
Now, density is the measure of mass per unit volume. So how much mass is in a given space? The units are kilogram divided by meters cubed. So kilogram meter minus 3. Right?
Yeah.
Okay. So regular shape measure mass using balance and volume by direct measurement of dimensions. Right? Irregular shape mass using balance again and volume using displacement methods. Do you remember what displacement methods were?
Could you recall them so I can remember?
Okay. So when we have a solid object, we would place that into a beaker which has already measured amount of liquid. So when the solid moves inside, there's a displacement of that volume, and we calculate that displacement, and that is the volume of the solid object. 1 milliliter is equal to 1 centimeter cube, right? So we can directly convert that into centimeter cube, giving us the volume of this solid as 200 centimeter cube, right? Similarly, if we have a displacement can, what we can do is we place this solid object within this beaker, and the water before adding this solid would be level at the tip of this nozzle, and as soon as this object is added, the water will be displaced upwards and downwards through this spout into a measuring cylinder which can measure how much volume of water is displaced. When you've done that, you will find out the volume of this solid object. Yeah? So this was for solids. Now, if we have a liquid, we have to measure the mass of a liquid. So what we'll do is, first thing first, we'll take a beaker. right? So we'll take a beaker, and the first thing that we'll do is we'll measure the weight of this beaker, mass of this beaker, right? Empty mass ले लेंगे. We'll get the mass x, right? And then we will add the volume of water or any liquid. So we'll get x plus y, right? Then when we subtract these two, we get y, which is mass of liquid, right?
Yes.
Right? Now, okay. So now we have the mass of the liquid, and if this is a beaker or a measuring cylinder, we can measure the volume directly through the readings on the beaker or the measuring cylinder. Yeah. Now you needed two things to find the density. You had the volume and the mass. So now you have both. Hence, you can take out the density.
Sir, give me a moment.
Okay. Right. So now you have the mass and the volume. So you can take out the density. When we're talking about air, you'll take a flask filled with air, right? And then you'll measure the mass with the air. So you'll get x plus y first, right? So flask plus air. Then you'll vacuum the flask and you'll measure the flask after. So this is just flask. And you'll check the difference,
Yes.
which will give you air. Then you can take the entire volume of the flask, which is mentioned usually. Right? So you can add volume of water to the flask and find out how much volume was occupied. And therefore you have mass over volume again, which gives you density. Yeah. So if you have 63 grams of a certain copper mass and it has 7 centimeter cubes of volume, you have 9 GCM cube, which is your density. Okay. So now that you have the density, the mass of an aluminum sheet with a volume of 73 centimeter cubes and a density of 2.7. So mass over volume, mass over volume is equal to density, right? If you want the mass, you can rearrange this as mass is equal to density into volume. Yeah. Yes.
Yes.
Okay. So floating and sinking. This is our final concept. We'll stop before forces because I have another class as well. But we've done weight, mass, and we've done density. So objects float or sink in liquids based on their density. Higher density objects will sink in lower density objects, whereby vice versa, lower density objects will float in higher density liquids. Okay, for example, oil has a lower density than water, which is why it is floating above water when they are mixed together. Okay. Any questions regarding mass, weight, and density?
No, I'll revise this all over again in a bit, and then if I have any other additional questions, I'll just ask in the group chat.
Okay, no issues. Okay, any further questions?
No,
Okay, Lafis.
office.